A half adder is one of the simplest combinational logic circuits used in digital electronics. It performs the addition of two single-bit binary numbers. Half adders are used in basic arithmetic units inside processors, calculators, and digital systems. They're the building blocks of larger circuits. As shown in the truth table, the sum acts like an XOR operation, whereas the carry functions like an AND operation. So, let's continue with Verilog coding of half adder. Let's continue by writing the test bench. Here we have the complete test bench file, where every possible condition has been thoroughly tested. As demonstrated by the test bench results, our RTL code has been successfully implemented and fully satisfies the expected truth table. Next, we'll look at the waveform results to see how our design performs.
With this, we have completed both the RTL implementation and verification. As the next step, we will synthesize the RTL using the Yosys open source tool and examine how the tool processes our design. On the right side, you can see our backend main script, while on the left side, the Yosys shell is displayed. Here on the GUI, our behavioral RTL is displayed. The reason for this is that we have not yet optimized the RTL using Yosys. As shown on the GUI, after optimization, Yosys produces the most efficient form. The sum is the XOR of A and B, while the carryout is the AND of A and B. Here you can find the final net list.